All right, 4C number 2. So 4C is covering quite a few different things. This one we're solving, again, quadratics, but we're going to solve by factoring. Sometimes quadratics are easiest to solve by factoring. And so I'm going to give you a couple situations here. So we are going to take example 1, which is x squared plus 9x plus 14, and we're going to factor this. What two binomials are going to multiply to get this? Well, what we're going to do is you're going to figure out your A, B, and C. So your A is 1, B is 9, and C is 14. And you're going to do A times C first. A times C is 14. And now you're going to take 14, and we're going to have factors of 14. Get all the numbers that multiply to 14. So 14 times 1 and 7 times 2. Well, there's also negative 14 times negative 1. Two negatives multiplied to a positive. All right. Next, we need to figure out which of these factors adds, if you add those up, which factors add to the B. The B is 9. So looking at 9 from here. And which one adds to 9? Well, that's a 7 and 2. Cool. Now we're going to use 7 and 2. We're going to use this in the Punnett square. So first was find out which two factors multiply to A times C that add up to B. And now we're going to use this in the Punnett square. So second Punnett square. Factoring. So there's different ways of factoring. I think this is probably the easiest. So you put the A term in the top left. So this is the A term in the top left. You have x squared. The C term in the bottom right. And the B term is kind of, well, it's not, we have two spaces left open and there's only one B. But what you're going to do is you're going to take that 7 and 2 that you got, and we're going to substitute those in. 7 and 2. Well, 7 plus 2 is 9, but we need 9x. So what we're gonna do is we're gonna put x's on both the 7 and the 2. It does not matter the order here you put these in. It could be 2x in the bottom left and 7x on the top right. Does not matter. All right, next we got to find the GCF of each term or each row. So find the greatest common factor of each row and column. So looking at the first row, x squared and 2x, what's the biggest thing you can divide out of both? Well, there's no number. 1 and 2 is just 1, but they both share an x. So x is your greatest common factor. You can divide out of both. You can't go x squared because 2x doesn't have an x squared. The bottom row, looking at between 7x and 14, the biggest thing you can divide out of both of them is 7. Looking at the first column, x squared and 7x, the only thing in common is x. And the last column, 2x and 14, the biggest number you can divide out is 2, and not an x because the 14 doesn't have an x. Well, you already factored. Great job. Our factors are 7, or x plus 7, and x ends a positive 2, so x plus 2. So really, we just took our original equation and broke it up into two binomials that would multiply to that trinomial, that 3-term quadratic. So we have it factored. Now we have to set, the last thing we have to do is set each, so third thing, set each factor equal to 0. So x plus 7 equals 0 and x plus 2 equals 0. These are going to provide both of our solutions. So we solve each one of these one-step equations. You get x equals negative 7. I bet you know what this one's going to be. X equals negative 2. There are your two solutions to the quadratic. All right, example 2. So first thing we got to start out with here is it's not in standard form. So we need to get all the terms to one side. I like to get the a term positive. So 3m is already positive, so they're 3m squared. So I'm going to keep it there. And I'll put the b term in the middle, and then a c term at the end. And again, we're going to follow that exact same pattern. So a times c. And now we're going to figure out, you don't have to name them all, but what two numbers multiply to negative 36? Negative 36 and 1, negative 18 and 2, negative 9 and 4, negative 6 and 6. Am I forgetting anything? Negative 12 and 3. 36 is a crazy number. It's got a lot of factors. You also have the other. So negative 1 times 36, negative 2 times 18. So I'm just switching the negatives on which number, because a negative times a positive is a negative. You don't have to write the negative 6 times 6. It's already there. And negative 3 times 12. Now, what we're doing here is we're trying to figure out which number adds up to 16. Which ones of these add up to 16? That's negative 16, so not that one. This one will add up to positive 16. 2 plus 8, negative 2 plus 18 is 16. Perfect. Those are our two numbers. Now we're going to take the Punnett square. Ooh, that's an ugly, ugly Punnett square. Let's do a better one. A little better. And we're going to put our numbers in where we need them to be. So top left is the a term. Bottom right is the c term. And now we're going to split it up with a negative 2 and 18. Doesn't matter which one it goes. Bottom left, I just put negative 2. You could put 18. And they have to add up to 16m. Right now, they don't have any m, so we got to put m on them. And now the last thing is to find the greatest common factor of each row. So greatest common factor of the top, or each row in each column. Top row, you have 3 and 18 is 3. And then there's an m squared and m. And a little secret when it comes to variables, it's just to find the greatest common factor is always the smallest number of m's, smallest exponents. This is m to the first, so you're going to take just an m out. Bottom row, negative 2m and negative 12. There's if the first term is negative, it's always a negative that you're going to take out. So between 2 and 12, it's 2. And it'll be negative because it's a negative 2. The first column there's just a 1 and an m, or just m. The last column, oh my goodness, 18 and 12 is 6. And I will just go through and make sure I got these so they're multiplied outright. 3m times m is 3m squared. 3m times 6 is 18m. m times negative 2 is negative 2m. And negative 2 times 6 is negative 12. So we have them all. Everything multiplied out. So you can always check that. That's a plus 6. So one of your factors is at m plus 6. And this is 3m minus 2. So there is the two binomials that would multiply to the original trinomial, the quadratic there. The last step is to set each factor equal to 0 and solve. And add 2. This is a 2-step. And a fraction, 2/3. All right, there's your 2. All right, come to class with